Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn something very important, that is how to convert Cartesian equations into pedal form. Okay, so I will just recap what all things we learned till now. In the first video, we learned about curvature and radius of curvature. And I hope you still remember. Curvature means you are comparing a curve with a circle. So you can see that point to point the circle becomes bigger, and if the curve becomes straight, the circle will become so big that it will become a line. And I also explained about radius of curvature being positive and negative, depends on the concavity and convexity, that is whether the curve is bent upward or downward. And I told you one more fact, that when the curvature is high, the circle will be very small, and when curvature is less, the circle becomes very big. And I think you are also able to see the point of inflection. Point of inflection means where that, can you see? The second order derivative will be 0, that is the bend will be gone, that is radius of curvature will be infinity. Okay, so this is what we discussed in the first video. And then in the second video, third video and other videos, what we learned is, we learned how to find the radius of curvature. First we learned how to find radius of curvature for Cartesian equation, and then whenever they give the equation in parametric form, and the last two videos whenever they give the equation in polar coordinate form or polar form. Now we are not going to calculate radius of curvature right now, but later we will learn how to calculate radius of curvature in pedal form. The main reason we convert Cartesian equations and polar equations into pedal form is, sometimes in comparison with the Cartesian form and the polar form, the pedal form will be very cute. Let's say if the Cartesian equation is this long, the pedal form may be very like what you call compact. And one more thing, the radius of curvature calculation in pedal form is very easy. So that is the reason we convert Cartesian equations, polar equations into pedal. We cannot say every time, but many times the pedal equation looks simpler comparatively to the Cartesian and polar equation. Okay, now let's come to the point. And in your examination, they may not ask you to find radius of curvature from pedal, but they may ask you convert this Cartesian equation into pedal, or they may ask convert this polar equation into pedal. Okay, so let's just check out what is this pedal form. I think you remember Cartesian equation, what we do is we draw the x-axis, y-axis, and every point in the 2D will be given a unique identity with respect to the origin. In polar coordinate system, what we do is we draw the pole and the initial line, and every coordinate will be given its position by the straight line distance from the pole and the angle, that is r comma theta form. Now in pedal, what we do is, okay, look at this. Suppose we have a function in the Cartesian coordinate system, y is equal to f of x, or the implicit form f of xy equal to a square. So either explicit or implicit. Now let's say the graph looks like this. Now look at this. In the Cartesian system, for example, if I consider this particular point, the name of the point will be x comma y. Now look at this. I am going to draw a tangent at the point. Now in the pedal system, what we do is we measure the distance of the tangent from the origin. What do we measure? We measure the distance, in the sense perpendicular distance. So we measure the distance of the tangent to the origin. And we also measure the straight line distance from origin to that point. That is of course r, like this r. And this perpendicular distance will be denoted by p. So this coordinate will be called r comma p or p comma r in the pedal format. Okay, once more let me explain. Let's say we have a curve. Now what we do is, if you want to convert this into pedal form, look at this. First of all, you should understand this curve is made up of many points, and in Cartesian system every point will be represented by x comma y. Now if you want to convert this into the pedal form, what you do is you just draw the tangent and then measure the distance of the tangent from the origin. That will be called small p. You also measure the straight line distance from origin to that point, and that will be called r. So if you measure like this, every point will have a p and every point will have an r. And our Cartesian equations will be converted into p comma r form, and that form is called the pedal form. So one last time I'll repeat. Consider a curve. And remember, in this video we are discussing how to convert Cartesian form into pedal form. Okay. So remember, in Cartesian form every point in the curve will be called x comma y. Now if you want to convert into pedal form, what you do is you just draw the tangent at the let's say each and every point, or let's say a representative point. Now what you measure is the perpendicular distance of the tangent from the origin. That measurement is p, and you also measure the straight line distance of the origin to the point, from origin to the point, and that will be called r. That means every coordinate which was in the form x comma y will be converted into the form p comma r, where p means distance between origin and the tangent at the point, and r means the distance between origin and the coordinate. And if you are able to convert the Cartesian equation which is in xy form into pr form, then that means you have converted the Cartesian equation into pedal form. Okay, let's try one problem. But before we start, let me give you some information. Point number 1. You may have to derive the equation of a tangent. So look at this. In order to do this, what we normally do is we assume every point in the given curve is small x comma small y, and every point in the tangent to be capital X comma capital Y. And the equation of the tangent is given by y minus small y is equal to dy by dx into x minus x. So please note this point. And in the case of ellipse, hyperbola, parabola, you can use the equation of tangent directly from your knowledge from class 12 and also from first semester engineering. If you want, you can derive, but that will be just wasting your time. So if you remember the results from ellipse and hyperbola, parabola, etc., that will be a huge advantage. For circle also you can use it. Now in case you do not remember, or in case they ask a new curve, new system, then you have to derive. So please note this equation of tangent. Now next thing, distance between tangent and the origin. So this is our P. Do you remember? P means the distance between origin and the tangent. Now look at this. Our tangent will look like ax plus b capital Y plus c is equal to 0, because I told you every point in the tangent, to avoid confusion, we take it to be capital X capital Y. Now distance between origin and tangent, small p is given by mod c divided by root under a square plus b square. So please note this point. So point number 1, equation of tangent. Point number 2, distance between origin and the tangent. So this is the formula for P. Okay, now the third one. We have the curve and we have every point small x comma small y. So we need one measurement, that is the distance from origin to the point, that is our r. Now look at this. You can simply use Pythagoras theorem or polar coordinate system or whatever. R is given by the relation x square plus y square. You can use Pythagoras theorem, that's the easiest. This is x, this is y, so r square equal to x square plus y square. So I hope you're okay with the formula. Now we will do one problem in this video and the remaining problems in the next video. Okay, let's start with something which you are familiar with. Okay, so let's say, write the question, find the pedal equation or the pedal form of the ellipse x square by a square plus y square by b square is equal to 1. Okay, I'll teach you two methods. Method 1, it is direct method. Method 2 is deriving the same thing from parametric form. You can use any method you like. Okay, let me remind you from the chapter ellipse, I'm going to borrow a result, that is equation of tangent. I'm sure most of you learned ellipse and hyperbola, and I hope you remember the equation of tangent at a particular point x1 y1 is given by x1 by a square plus y1 by b square is equal to 1. So you should either derive this or you should remember this as a result, and it is much better if you remember this. I hope you still remember. We learned this in ellipse first semester. So the equation of tangent at the point x1 y1 is x1 by a square plus y1 by b square equal to 1. Okay, so let's start. So how do you start? Let small x small y be any point on the given curve, that is our ellipse. Let capital XY be any point on the tangent at the point x comma y on the ellipse. So comparing with this equation, what will be the equation of tangent at xy? Can you guess? Yeah, it's very simple. Capital X small x by a square plus capital Y small y by b square is equal to 1. In the beginning there will be a little bit confusion, but in the next video when we do a lot of problems, you will get familiar to this concept. So look at this. Here like what you call x1 y1 is the point of tangent C, but here xy is the point of tangent C. So you can understand x1 becomes x and y1 becomes y. And here small x and small y means any point on the tangent. But in our method, capital XY means any point on the tangent. Okay, now let's write it in a equation of a line. That is x by a square into capital X plus y by b square into capital Y minus 1 is equal to 0. Okay, so we are ready with the equation of the tangent. Okay, now let's go back and let's see how do you find P. What do you mean by P? P means distance between origin and the tangent, and it is given by modulus of the constant part divided by coefficient squares. So let's write P. So P is equal to modulus of minus 1 whole divided by root under x square by a power 4 plus y square by b power 4. Let's square on both sides. P square equal to 1 divided by x square by a power 4 plus y square by b power 4. That is 1 by p square is equal to x square by a power 4 plus y square by b power 4. So let's call this as equation number 1. Now look at this. What is our job? I hope you still remember. We had to delete x comma y and we had to introduce p comma r. P is already injected, but we are not able to inject r. Remember, we have to delete x comma y, we have to insert p and r. Okay, now what is r is equal to? Yeah, x square plus y square. Okay, you can perform elimination in any way you like. Anyway, let's try for a method here. Okay, I'm going to destroy this y square first. So can you please tell me what is the equation of the ellipse? X square by a square plus y square by b square is equal to 1. So y square by b square is equal to 1 minus x square by a square. So I'm going to plug it here in equation 1. So equation 1 becomes 1 by p square equal to plus, I'm going to write this as 1 by b square into y square by b square. Are you able to understand? 1 by b square into y square by b square, so that I can replace it with, what can I do? 1 minus x square by a square. Okay, so that means 1 by p square equal to x square by a power 4 plus 1 by b square minus x square by a square b square. Now let's take that common. 1 by p square equal to x square common, then yeah, a square also common. So we get 1 by a square minus 1 by b square plus 1 by b square. That is 1 by p square is equal to x square by a square into, taking LCM, b square minus a square by a square b square plus 1 by b square. I think it's better to call this as equation number 1. So once more, let me tell our aim. Our aim is to destroy x and y and to insert p and r. We are almost successful. I have deleted y. Now only x remains and p is already inserted. Now I will focus on this part, r square part. Okay, once more, let me take the equation of, I'll repeat, you can do elimination method as you wish. Right now my brain is working like this. Maybe the next time I try, I may find an easier method. So it's up to you, you can try it. Okay, now again I am going to write x square by a square plus y square by b square is equal to 1. And this time what I am going to do is, I am going to write x square in terms of our r. So I am going to write this as x square by a square plus, what can I do with y square? R square equal to x square plus y square. So y square can be written as, okay, now let's take LCM, b square x square plus a square r square minus a square x square equal to a square b square. I have skipped step. Do it slowly. Take LCM, distribute these things. So I have skipped 2 steps. Okay, now take common. X square into b square minus a square is equal to a square into b square minus r square. So x square is equal to a square into b square minus r square divided by b square minus a square. That's it. We are almost done. Look, now what I did is I'm writing x in terms of b and r, a and b. Now that's it. I'll plug it here. So let's see what happens. 1 by p square equal to x square. This is our hero. What should I do with x square? Yeah, a square into b square minus r square by b square minus a square, okay, into 1 by a square, this one, and then b square minus a square by a square b square plus 1 by b square. That's it. This is our pedal equation. Now we have to write it neatly, but this is our pedal equation. One last time, let me tell you, our job is very simple. Delete x comma y and convert it into p comma r. So 1 by p square is equal to, and to be honest, there is no regular method. You should use any elimination property which you have learned in younger classes. Just now my brain was working like this, but trust me, there might be even easier methods. You can try it. So the remaining part is b square minus r square by a square b square plus 1 by b square. Now let's divide and check it if we get something good. 1 by p square equal to b square. Okay, so we get 1 by a square minus r square by a square b square plus 1 by b square. So that's it. Our ellipse in pedal form is 1 by p square equal to 1 by a square plus 1 by b square minus r square by a square b square. Okay, one last time let me explain it so that you get a very clear concept. In this video, what we are learning is how to convert Cartesian equation into pedal form. So let's say we are given an equation in Cartesian form, and in Cartesian form every point corresponds to x comma y, and of course we take every point to be small x small y. In order to convert into pedal form, what we do is we draw a tangent at the required point, and then we measure two things: the distance of the tangent from the origin and the distance of the point from the origin. The distance of the point from the origin is denoted by r, and the distance of the tangent from the origin is denoted by p. And our job is to convert this x comma y into p comma r. I'll repeat once more. This is the pedal equation corresponding to our ellipse in Cartesian form. Okay, now let's do the same stuff with parametric form, method 2, because some people love to simplify with parametric form, and to be honest, I love parametric form. But the sad part is we don't know the parametric equations of some curves, so you should be very good in both methods. So don't forget equation of tangent. Anyway, we did not use because ellipse is a standard equation and ellipse is in your first semester syllabus. So as a first semester student, you're supposed to know the equation of tangent to an ellipse. Now the second result, distance between origin and the tangent. And the third one, the relation between r, x and y. Okay, so let's go for method 2. Please write method 2 using parametric form. Can you tell me the parametric equation of an ellipse? That is x is equal to a cos theta, comma, y equal to b sin theta. Now once more let me tell you, if you want you can derive the equation to the tangent. If you want you can derive the equation to the tangent, but I am not going to derive it, I am going to use it because ellipse is a topic in the first semester syllabus. So I am going to write the tangent to the ellipse in parametric form is capital X by a into cos theta plus capital Y by B into sin theta is equal to 1. You learned this derivation. I'll repeat once more. If you want, you can derive it. Okay, so that is cos theta by A into capital X plus sin theta by B into capital Y minus 1 equal to 0. So that's it. We have the equation of the tangent. I'll repeat. I'm using the equation of the tangent as a direct formula. Okay. Now, what is the definition of P? P means distance between origin and the tangent, and it is given by modulus of constant divided by root under coefficient squares. So cos square theta by A square plus sin square theta by B square. So squaring P square is equal to 1 divided by cos square theta by A square plus sin square theta by B square. That is 1 by P square is equal to cos square theta by A square plus sin square theta by B square. Okay, now don't forget what is R square. R square is x square plus y square. That is R square is equal to x means A cos theta in parametric form, A square cos square theta plus B square sin square theta. Okay, now look at the advantage of parametric form. In parametric form, look at this. In parametric form, both x and y will be written in terms of theta. Now, remember, when we convert an equation into pedal equation, we need the answer in terms of P and R. What do we need? We need the answer in terms of P and R. When we applied method 1, we had a really hard time because we had to eliminate both x and y. But the advantage of parametric form is, here we have to eliminate only one person, that is theta. Are you able to see the advantage? In parametric form, we have to eliminate only one variable, that is the parameter. We have to eliminate only theta. And that is the advantage of parametric form. Yeah, so 1 by P square is equal to, I can see exactly the, not exactly the same thing, something similar. So look at this. So B square cos square theta plus A square sin square theta by A square B square. Okay, A square B square by P square is equal to B square cos square theta plus A square sin square theta. Now once more let me ask you, what is our job? Our job is to destroy theta but to introduce P and R. Okay, so it's very easy. You know the result. Sin square theta plus cos square theta will be 1. Sin square theta plus cos square theta will be 1. So all you have to do is you have to do equation 1 plus equation number 2. So we get R square plus A square B square by P square is equal to, think about it, A square cos square theta plus A square sin square theta, that will be A square. B square sin square theta plus B square cos square theta, that will be B square. That's it. See, we get the same equation. We get the same equation. Look at this. If you want, you can like what you call divide throughout by A square B square. If you want to see the other form, look, R square by A square B square plus 1 by P square equal to A square by A square B square gives you this and this. See, the same equation we derived earlier. 1 by A square plus 1 by B square minus R square by A square B square. So that's it. So I'm going to wind up this video right now. In the next video, we will be doing like what you call 3 very important questions in which we will convert Cartesian equations into pedal format. So till then, my friends, bye.